Hello, everyone, and I'm back here, online math mentor, and this has been the fourth part of my lecture series for the basic integration formulas. And on this video, I'll be discussing with you some basic techniques on how to integrate some trigonometric functions. But before that, allow me to show you some or the derivatives of the six trigonometric functions, namely derivative of sine u is cosine of u du, derivative of cosine u is negative sine u du, derivative of tangent u is secant squared u du, derivative of cotangent u is negative cosecant squared u du, derivative of secant u is secant u tangent u du, and finally the derivative of cosecant of u is negative cosecant of u cotangent of u du. And using this relationship, we can now say that the integral of cosine of u du is sine of u plus c. Integral of sine u du is negative cosine u plus c. We also have the integral of secant squared u du is tangent u plus c. The integral of secant squared u du is negative cotangent u plus c. And then the integral of secant u tangent u du is secant u plus c. And finally, we also have the integral of cosecant u cotangent of u du is negative cosecant squared u plus c. And another trigonometric function that we might get interested with is the integral of secant u du, which is equal to ln secant u plus tangent u plus c. And before I proceed with the next set of formulas, let me verify this integral. We know that the integral of secant u, okay, du is equal to ln secant u plus tangent u plus c. So what I'm going to do here is I will just multiply this by 1 of the form secant u plus tangent of u all over secant of u plus tangent of u. And then multiplying, I shall now have, you know that the denominator is just simply equal to secant u plus tangent u. Then the numerator would have been equal to secant u times secant u is secant squared u plus secant u times tangent u is secant u tangent u, and then you just simply affix du. And then from here, we can now, by change of variable, we can now let v equal secant u plus tangent u. And then differentiating, then we can now see that that's dv equals secant u tangent u plus secant squared u, and then you just simply affix du. Okay, and then we can now observe here that this numerator is in fact our dv and the denominator is our v. And looking at here, so that will lead us to ln of v plus c, and therefore we can now verify that the integral of secant u du is ln of v, which is secant u plus tangent of u plus c. And then by applying the same procedure, you can now verify that the integral of cosecant u du is ln cosecant u minus cotangent of u plus c. Similarly, the integral of tangent u du is equal to ln of secant u plus c. And since secant u is equal to 1 over cosine of u plus 1 over cosine of u by reciprocal identity, and therefore the integral of tangent u du can also be written as negative ln of cosine of u plus c. And similarly, we also have the integral of cotangent u du, which can be expressed as ln of sine of u plus c or negative ln of cosecant of u plus c. And let's have some example. We have integral of sine x dx, and you know that the integral of sine u du is negative cosine of u plus c, and therefore the integral of sine x dx is negative cosine of x plus c. And then I will be modifying this example by writing 3 here. So you have integral of sine 3x dx. So you know that u is equal to 3x and du is equal to 3 dx. Since we only have dx here, you can just multiply this by 1/3. That will become 1/3 du is positive dx. And therefore, that can now be written as the integral of sine, then that 3x is our u, and that dx is represented by 1/3 du. Integrating, you know that the integral of sine u is negative cosine of u, and then you add c, and therefore the integral of sine 3x dx is negative 1/3 cosine of 3x plus c. Another one. So you have integral of cosine 3/4 x dx. By applying the result of number 2, you know that the derivative of 3x is equal to 3, then we already have here dx, and then you just get the reciprocal of that 1/3. So doing the same, we know that the derivative of 3/4 x is 3/4, then you already have dx here, then you can write it as, you get the reciprocal, that's 4/3, okay? And then you integrate cosine, that's positive sign, and then you just simply copy 3/4 x, and then you add c. Finally, the integral of cosine 3/4 x dx is 4/3 sine 3/4 x plus c. And then integral of secant 5x tangent 5x dx, you recall that the integral of secant u tangent of u du is secant of u plus c. And here, u is represented by 5x, and you know that du is 5 dx. You look at here, there's only dx, so 1/5 du is positive dx. So therefore, that is equal to 1/5, then secant u affix 5x, and then plus c. Okay, so finally, you have the integral of secant 5x tangent 5x is equal to 1/5 secant of 5x plus c. Another one, okay, so integral of secant 3x dx, and you know that the integral of secant u is ln of secant u plus tangent u plus c, okay? So you know that the derivative of 3x is 3 dx, so you only have dx here, so you just get the reciprocal of 3, you just write it in front, so that's 1/3, and then you affix ln, you copy secant, affix 3x, plus tangent, simply write 3x, and then you add c. And finally, the integral of secant 3x dx is 1/3 ln of secant 3x plus tangent 3x plus c. Another one, so this time we have integral of tangent square root of 3x dx. Again, we let u be equal to square root of 3x, and then du is square root of 3 dx, or 1/3 or 1 over square root of 3 du is equal to dx. So this is now equal to 1 over square root of 3. You know that the integral of tangent is ln of secant square root of 3, then copy x, and then you add c. Okay. Now we have the integral of tangent square root of x over square root of x dx, and we also have u equals square root of x, and that is equal to x raised to 1/2 du, okay, is 1/2 x. You subtract 1 from 1/2, that's negative 1/2, and then du. Okay, and you only have here dx over square root of x. So what I'm going to do here is I will just multiply this by 2. So you have 2 du equals, sorry, this one is dx all over, since this is x raised to negative 1/2, when you get the reciprocal of that, you'll have x raised to 1/2 or square root of x. And therefore, this is equal to integral of tangent square root of x is our u, then this dx over square root of x is 2 du. Integrating, you have 2 ln of secant, then square root of x, and then plus c. So you have 2 ln of secant square root of x plus c. Finally, we have, okay, integral of x squared cosine to x cubed dx. And you know that when you let u be equal to 2x cubed, you know that the derivative of this is equal to 6x squared dx. And you have here x squared dx, so you shall have 1/6. And then you know that the derivative of, the integral, sorry, the integral of cosine is positive sign, and you just copy 2x cubed, and then you add c. So finally, the integral of x squared cosine 2x cubed dx is 1/6 sine 2x cubed plus c. Okay, another one. We have integral of e to the x sine e to the x dx. Again, you know that the derivative of this e to the x is e to the x dx, so you shall have negative cosine of e to the x plus c. We have, integral of sine x plus cosine x squared. We first simplify the integrand by expanding sine x plus cosine x squared. And that will lead us to square of the first, that's sine squared x, twice the product of the first and the second, that's 2 sine x cosine x, plus square of the second, that's cosine squared x. And you know that this sine squared x plus cosine squared x by square identity, that is equal to 1. and this is equal to sine 2x by double angle identity. So we shall have the integral of 1 plus sine 2x, and then integrating, you know that the integral of 1 dx is x, and the integral of this is 1/2. Integral of sine is negative cosine, then you just simply copy 2x. And we shall now have in x minus 1/2 cosine of 2x plus c. Okay, another one. Okay, integral of dx all over secant of 2x times the quantity 2 minus sine 2x. So we can now let u by change of variable be equal to 2 minus sine 2x, and differentiating, you have negative 2 cosine 2x dx, that is our du, and multiplying by negative 1/2, that will lead us to negative 1/2 du equals cosine 2x dx. Unfortunately, when you look at the given, there's no cosine 2x here. However, when I notice this secant 2x on the denominator, when that is written on the numerator, since by reciprocal identity, 1 over secant, remember this one, 1 over secant of x is cosine of x. And therefore, we can now write this as integral of cosine 2x dx all over 2 minus sine 2x. And then this can now lead us to, remember this cosine 2x dx is negative 1/2 du, and then this one is our u. So you have negative 1/2 du over u, and that led us to an ln function of the form negative 1/2 ln of u plus c. Writing it back to the original variable, that gives us negative 1/2 ln of 2 minus sine 2x plus c. And then by applying the result of this example, we can now simply integrate cosine x dx all over 1 plus sine x. You know that the derivative of 1 plus sine x is cosine x dx, which can be found on the numerator. Therefore, that leads us to ln of 1 plus sine x plus c. Okay, another modification of this problem is that what will happen if this cosine x is no longer present on the integrand. Say we have integral of dx all over 1 plus sine x. So to do this, what I'm going to do first is I will just multiply both the numerator and denominator by the conjugate of 1 plus sine x. And that is 1 minus sine x all over 1 minus sine x. Multiplying, this will lead us to the integral of 1 minus sine x all over, you know that the denominators happen to be sum and difference of two binomial with similar terms, then their product is 1 minus sine squared x. And this 1 minus sine squared x by square identity, that's cosine squared x. So we shall now have integral of 1 minus sine x all over cosine squared x. And then again, by distributive property of division over addition, we shall now have integral of 1 over cosine squared x minus sine x over cosine squared x dx. And remember, by square identity, you have 1 over cosine is secant, and therefore, this 1 over cosine squared x will become secant squared x. So for the second term, I can just write it of the form 1 over cosine x times sine x over cosine of x. And this 1 over cosine x is secant x, and this sine x over cosine x is tangent of x. And therefore, we shall now have integral of secant squared x minus secant x tangent x dx. And these two are directly integrable, direct integrable of the form tangent x, that's the integral of secant squared x dx, and the integral of secant x tangent x dx is secant x, and then you just simply affix the minus sign. Okay, and therefore, the integral of dx all over 1 plus sine x is tangent x minus secant x plus c. Okay, we also have here a product of sine x and cosine x dx. When you look at it, okay, so we have here sine and cosine that go along together as part of the integrand, and both of them has power of 1 and of the same parameter. Okay, so here, I will show you 3 ways on how to treat this kind of problem. The first one is by setting u equals sine x, since the derivative of sine x is cosine of x dx, which is present on the integrand. And then for the next solution, since the derivative of cosine is negative sine, which you can also find it on the integrand, then you can let u be equal to cosine of x. Okay, so by doing the first method, so we have du equals cosine x dx, okay? And then finally, this sine x cosine x dx can be written of the form, again, this is your u and this is our du. So that's integral of u du, and when integrated, that leads us to u squared over 2 plus c. And then writing it back to the original variable, you have 1/2 sine squared x plus c. For the second example, if we let u be equal to cosine of x, then that's du will become negative sine x dx, or negative du is positive sine x dx. And then by change of variable, we can now have integral of sine x cosine x dx. This is our u, and this 2 will represent negative du. So you have negative integral of u du. Integrating, that will lead us to negative u squared over 2 plus c, and then writing it back to the original variable, that leads us to negative 1/2 cosine squared x plus c. Okay, and then, okay, comparing these two answers, so we can now say that they are not equal. However, by simply using the square identity, let me just show it to you. So you have negative 1/2 times cosine squared x is 1 minus sine squared x, and then you add c. And then multiplying negative 1/2 by 1, then plus, that's negative 1/2 times negative sine x, that's positive sine squared x plus c. Remember, this is constant. This is also constant. When added, that leads us to another constant. So finally, that will become 1/2 sine squared x plus c, and we have achieved already our purpose of making these two expressions equal. Okay. Then for the next method, I'll be using the double angle identity. You know that sine 2x is equal to 2 sine x cosine x, and this is only sine x cosine x, then we just multiply it by 1/2. So 1/2 sine 2x is positive sine x cosine of x. Then we can now rewrite it of the form 1/2 integral of sine 2x dx, and you know that the integral of this is negative 1/2, okay, cosine 2x. And finally, the integral would have been equal to negative 1/4 cosine of 2x plus c. And this can be equal to this two expression by using the square identity. Cosine 2x is cosine squared x minus sine squared x. Okay, and then we shall now have another example, sine 3x cosine 4x dx. Looking at our example here, so we cannot let u be equal to sine 3x since the derivative of this is not equal to cosine 4x dx. Similarly, when this is equal to our u, then the derivative of this is not equal to this. Okay, so what are we going to do is we just simply rewrite this by applying the product to sum identity. You know that sine x cosine y is 1/2 sine of x minus y plus 1/2 sine of x plus y. And then x here is represented by 3x, and this y is represented by 4x. So we shall have the integral of 1/2 sine 3x minus 4x plus 1/2 sine 3x plus 4x. And then simplifying this to, we have integral of 1/2 sine of negative x plus 1/2 sine 7x. And you know that by add even identity, we know that sine of negative x is negative sine x. And then this can now be rewritten as negative 1/2 integral of sine x dx plus 1/2 integral of sine 7x dx. And you know that the integral of sine x dx is negative cosine x plus c. And then we shall have, and also the integral of sine 7x dx is negative 1/7 cosine 7x. And then finally, we have positive 1/2 cosine x, then minus 1/14, that's 2 times 7, then cosine of 7x plus c. And therefore, the integral of sine 3x cosine 4x dx is 1/2 cosine x minus 1/4 cosine 7x plus c. And I think that's the end for now. And you keep on tuning onto my channel. I'll be discussing more of powers and products of trigonometric functions.